Okay, pre-calc students, in this video we will be using trig identities to evaluate trig functions. It would probably be wise to have out your trig identity sheet. We're going to use those throughout this video, so please have those out. Your heading for today is evaluating trig values by using trig identities. Once again, your heading today is evaluating trig values. That really should be trig functions. There we go. Evaluating trig functions by using trig identities. Evaluating trig functions by using trig identities. The lesson number is 10.1. The lesson number is 10.1, and be sure and include today's date. Okay? Be sure and include today's date. So I'll pause a second while you copy all this down. Evaluating trig functions by using trig identities, lesson 10.1, and be sure and include today's date. And let's roll. This will be a very short video. We're going to take our trig identities that we looked at before in a previous video, and we're going to apply them to problems, and we're going to find the values of trig functions, okay? Here's our first problem. Please copy this in your notes if you would, please. Copy this down, please. We're going to use the values secant of u equals -3/2 and tangent of u is greater than 0 to find the other 5 trig function values. Now you're probably thinking, Mr. Earhart, we've done this before. We've drawn our triangle in the right quadrant, and we've put u here, theta here, and we've labeled our triangles. That's true. But on your upcoming tests and quizzes, I'm not going to allow you to do it this way. We're going to use our trig identity. So let me show you what we're going to do here. We're going to find the other trig values. In fact, I'm going to go ahead and write those down now. You might want to do the same thing. We know what secant is, so we're looking for the sine of u, the cosine of u if you want to write this down, and the tangent of u, and the cosecant of u, the secant of u, and the cotangent of u. Now, we already know the secant of u is -3/2, so we can fill that in. Now, the only reason you need to draw a triangle is to very quickly make sure you're in the right quadrant. So listen to me, students, so you know whether or not your sine or your cosine or your tangent will be positive or negative or whatever the sign will be. So let's very quickly find out what quadrant we're in, and then we'll know what signs to use over here, and then we can go on and use our trig identities. Okay, so here we go. We're looking for a quadrant in which secant is negative and tangent is positive. So real quick, let's just throw these up here real quick. Positive, negative, 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 positive. Negative, positive, negative. Now you're looking for a quadrant where secant is negative, and of course the reciprocal function for secant is cosine. So where is cosine negative? Here and here. So it's going to be one of these two quadrants here. Now we're looking for the quadrant where tangent is greater than 0 or tangent is positive, and that would be here, not here. So we're dealing with the third quadrant. So here we go. This quadrant right here. So very quickly, students, label all of your signs over here correctly, and then we'll get rid of this this coordinate plane over here. So your sine is going to have a negative answer. Your cosecant will have a negative answer. Your cosine will have a negative answer because of this here and this here. Your secant will have a negative answer. Your tangent will have a positive answer. And your cotangent will have a positive answer. Okay, there we go. Now we're ready to use our trig identities. And so here we go. Let's go really quick, okay? I really feel like we should space these out a little bit, so I'm going to do that quickly, and booyah. There we go. Now, all right. Now, if secant is -3/2, then cosine would be -2/3. We know that, okay? Now, once I know cosine, I can find sine very quickly by the Pythagorean identity. Sine squared of theta plus cosine squared of theta equals 1. So I'm going to, really I should put u there, sorry about that, u. So sine of u squared, sine squared u plus, now cosine of u is -2/3. So I'm going to put -2/3, but I'm going to square it because it's cosine squared equals 1. So next I would have sine squared of u plus -2/3 times -2/3 would be 4/9 equals 1. Now bring the 4/9 over and make it a -4/9. So when you do that, you're left with sine squared u equals, now 1 minus 4/9 would be 5/9, and then take the square root of both sides, and so you would get sine of u equals, well, the square root of 5 is the square root of 5, and the square root of 9 is 3. Now students, you're used to putting plus minus in front of these when you take the square root of both sides, but remember, we already know what the sign of sine is, if you will, and it's negative, so I don't really need to put the plus minus. Okay, so sine is negative square root of 5 over 3. Now, if that's the case, then over here I know cosecant is 3 over square root of 5. And of course, if you rationalize the denominator, you're going to end up with this right here, 3 square root of 5 over 5. Of course, it's negative. Now, how can I find tangent real quick? Well, I'm glad you asked. Very simple. Very simple indeed. Remember your quotient identities, and one of them is tangent of u equals sine over cosine, and that's a u, not a 4. So tangent of u equals sine of u, which is, and I don't care about the sign. You're welcome to put negative square root of 5 over 3. I don't care about the positives and the negatives because I already know my sign's going to be positive anyways for tangent, so it's not really a big deal. But I'm going to go ahead and put square root of 5 over 3 for sine, and then the denominator I'm going to use cosine of u. So cosine of u is right here, 2/3. So there's what tangent equals. So all you have to do, students, is take square root of 5 over 3 divided by 2/3, or in other words, times 3/2. Your 3's cancel, and square root of 5 times 1 is square root of 5, and 1 times 2 is 2. Booyah. Okay, and a little sound effects there. Now take this and flip it, and you would get 2 over square root of 5, and of course if you rationalize the denominator, you'll get 2 square root of 5 over 5. There we go. We just knew one trig value. That's it. You say, no, Mr. Hart, you knew 2. I didn't know the trig value of tangent. I just knew what quadrant I was in. I didn't know anything else. And just from knowing that one trig function, that one trig value, and then using trig identities, I could quickly find the other 5 values. Okay, so pretty cool. Okay, now this next problem here is almost identical to the one we just did, so I would like you guys to pause the video. I want you to totally try this on your own. Don't forget to find out what quadrant you're in, so you use the correct positives and negatives, and then when everybody's done, go ahead and turn the video back on and see how you did. Okay, students, hopefully you're done by now. Here we go. Quickly, let's find out what quadrant we're in. Okay, there we go. Now, we want the quadrant where secant is positive. That's cosine. So that would be here or here. Okay. And then we want the, out of these two quadrants here, we want where sine is positive. So that would be here, right here. Here, right here. Okay, here. So we're going to be dealing with quadrant 1. Okay. So now that we know that, there's really nothing tricky to worry about. We know we have sine of x, cosine of x, tangent of x, and then cosecant of x, secant of x, and cotangent of x, okay? And we know everything's going to be positive because we're in the first quadrant, so nothing really tricky there to worry about, okay? All right, well, here we go. The one trig identity we know is secant of x is 4. So if secant of x is 4, then cosine of x would be 1/4. We're going to flip the 4, and then just like the last problem, we know cosine. So very quickly, using our Pythagorean identity, sine squared plus cosine squared equals 1. So sine squared plus, and cosine of x is 1/4. So I have 1/4 squared equals 1. Then I have sine squared x plus 1/16 1 times 1 and 4 times 4 equals 1. Then bring the 1/16 over and make it negative, so 1 minus 1/16. And that would be sine squared equals 15/16. And then take the square root of both sides, and you're left with sine of x equals square root of 15 over 4. Because the square root of 15 we don't know, and the square root of 16 is 4. So there we go. Slide it on over here, and we have the answer for sine. Okay. Well, if we have the answer for sine, hopefully you guys did okay on this problem. We then know that cosecant would be the reciprocal, so 4 over the square root of 15. And of course we're going to flip that, so we would get, or we're going to rationalize that, so it'd be 4 square root of 15 over 15. And then let's deal with tangent here real quick. Let's use cotangent this time. Either way you'll get it right. There's also a quotient identity, cotangent of x equals cosine over sine. All right. And if you used tangent, you'll get the same answer. It's totally fine. Okay. So cotangent of x equals cosine of x 1/4. Sine of x is square root of 15 over 4. So really, cotangent of x would be 1/4 divided by, or times, we're going to flip the bottom fraction, so times 4 over square root of 15. So 1 times 1 is 1. 1 times square root of 15 is square root of 15. And so if you rationalize that, that's your cotangent. So cotangent of x equals 1 over square root of 15. So if we rationalize that, we'll get square root of 15 over 15. And then, of course, if cotangent of x equals 1 over square root of 15, which it does, we just rationalized it here, but it does equal this, then if we flip this, we'll get square root of 15 over 1, so square root of 15. Okay, so I hope you got those correct. And let's go ahead and continue on. One more problem and we're finished. Now this one's a little different, okay? This one's a little different because notice we're dealing with, well, I did not mean to do that, but that's okay. Here, notice that we have sine of x equals negative equals -1, and cotangent equals 0. Now I've taught you guys, unless you're dealing with tangent, now remember, tangent of 45 is 1, okay? But other than tangent or cotangent equaling 1, other than that, when you're getting 1s and 0s right here, you're dealing with quadrant angles. So that means you're either dealing with 0 or 90, that's a really good 90, or 180 or 270 or 360. So usually I tell you guys to draw your coordinate plane and then list out your signs. But in this case, I'm not going to do that. Instead, what I'm going to do, because sorry, excuse me, the angle that I'm dealing with is not going to fall in a quadrant. It's not going to fall here or here or here or here. It's actually going to lie on one of my axes. Okay, so it's really going to be difficult to know what sign to use. So I'm not going to worry about my quadrants. Let me pause and say this, students. There is a way to know the positives and negatives of your 6 trig functions when they fall right on an axis angle. There is a way to do that. I'm not going to get into that now. Okay, maybe later on this year we will. I'm not going to get into that now. But because the angle that I'm dealing with does not lie in one of the quadrants, I'm just going to very carefully watch my signs as I use my trig identities. Let me show you what I mean. Watch carefully, you'll understand, okay? So I've got sine of x, cosine of x, tangent of x, and I have cosecant of x, secant of x, and then cotangent of x. Now, sine of x is -1, and cotangent of x is 0. Now, watch this carefully. If I flip -1, I get -1. And I've taught you guys, if I flip 0, I get undefined. So if cotangent of x is 0, then tangent is undefined. Now, let's take a quick look here. What was I going to use? Oh, if I know that cotangent is 0 and I know that sine is -1, the first thing I think of, students, would be this: cotangent of x equals cosine of x over sine of x, like this. Okay? And now cotangent of x is 0. Cosine of x is what we're looking for, so we'll just put cosine x. And then sine of x is -1. Let me pause and say this. Some of you are probably saying, Mr. Earhart, why not use the Pythagorean identity? Because we have sine squared plus cosine squared equals 1. Well, let me tell you why I didn't want to use this. In the very end of this, now listen to me, you're going to have to take the square root of one side and the square root of the other side. And so you're going to have to put plus minus in front of a radical. And remember, we don't know what the sign of cosine is. We don't know if it's positive or negative. Now, the last problem we did, because we knew what quadrant we were in, and the problem before that we did because we knew what quadrant we were in. But this problem here, we don't know what quadrant we're in. So because of that, I did not want to use a trig identity where I had to take the square root of both sides and not know what sign to use. Okay, so that's why I'm using the quotient function cotangent equals cosine over sine. So cotangent equals 0, cosine is cosine, sine's -1. Now, if I'm trying to solve for cosine, I'm going to multiply both sides by -1 to get rid of the denominator. So if I multiply 0 by -1, I get 0. If I multiply this side by -1, the -1 would cancel, leaving me with cosine. So there we go. The cosine of x is 0. And then, of course, if the cosine of x is 0, then the reciprocal, if I flip 0, I'm going to get undefined. Okay, so there we go. I hope that helps. Call or email if you have any questions. But once again, a video on taking trig identities and finding or evaluating trig functions using trig identities.